be doing Google Kickstart. And yeah, it's been a while since I last did it. But look at this, round E2021 is starting in 8 days. Yeah, it's a good time to practice again. So this time around, I hope that I can solve three whole problems. So like problem one, two, three. The fourth one, I think I can't solve it. It's my past experience is too difficult for me. Yeah, but eventually I hope that I will be able to solve the last problem as well. Okay, so let's just start. If you want to ask me questions regarding the problem or like what I'm coding, feel free to just ask in the chat. I'm monitoring the chat as well. So let's just first copy and paste a sample code. Maybe this ATMQ. I'll just rename it longest arithmetic. Okay, so oh wrong. I don't use Xcode. I want to use Visual Studios. So yeah, I only have about an hour today, so let's see whether I can do like two problems. Maybe the first two. If I can do three, that would be like awesome. I doubt that I can finish three in 1 hour. Okay, let's just try solving this one first. So when you first do Kickstart, you realize that like it might be very what do you call that, daunting, but actually it's not that bad. Yeah, you can just okay. So this seems like it's the longest. An arithmetic array contains at least two integers, and differences between consecutive integers are equal. Seem to have done this before. I mean, this looks very familiar. Like 9753 1337. Okay, so it has a constant difference. Okay, it has an array of n non-negative integers. I integer is a I. She wants to choose a contiguous arithmetic subarray from her array that have the maximum length. Okay, please help her determine the longest contiguous arithmetic subarray. That means like it must be stuck together. Okay, so let's okay, so this solve I can just delete this whole thing. Okay, so we just need to process this soft code right here. All right, so put a space here. Okay, so this is our code so far. Okay, what do we take in? So we just look at the input and output first. Input, uh, each test case has a line containing n, contains n integers. So we do a long n first. N is 2000, 2 times 10 to the power. Actually, n is an integer. Okay, 2 times 10 to the power 5 fits within an integer length. Yeah, so you can see the C++ integer data type max value. You can see that it can hold up to this amount here. So 2 times 10 to the power 5 confirm can fit in. Okay, so this is the n. Okay, and then what we want to do is the second line contains n integers. So for integer I equals 0, I smaller than n, I plus plus, we scan in this one. Okay, so what are this actually? So the ith integer, okay, the limits for this is, where's the limit for my integers? Ah, there we go, 10 to the power of 9. Okay, that means this is long. Okay, so maybe we have a vector. Okay, long, vector, long. I mean, I can do as an array as well. Yeah, but I'm more used to using vectors nowadays. The insertion time is linear. Reading time for vectors, it's also more or less linear because when the vector increases beyond a certain size, like it reallocates itself, so it's fine. Okay, so vector, what do you call this array? No, let's call it let's call it L. Yeah, L for list, or maybe like L for I just call it L. L dot push back. Okay, we push back our input. So X, let's call it X. Okay, so we do need to have a long X here. Okay, so for each number, we just scan in this, and then we just basically take in the input. Okay, and then we push it into our vector. Okay, that's all we are doing here. Right now, we need to find out how many of this. What's the longest sequence of consecutive like integers? I guess like consecutive difference. So I mean we can take the difference here. So this can be 10 minus 7 is 3, 3, 2, 2, 2. Okay, this is 2, minus this plus 2, this is 2, and this is 2 also. Okay, so you see 2, 2, 2, if you count this consecutive numbers, actually what we can do is we can have an array called a difference. Okay, we just take in the difference between the two numbers. Okay, and then we just count the number of times this difference is the same. Yeah, this will give us already the maximum length of the difference, and then we just plus one to get the max length. Okay, so what do I mean by that? Let's just code it out. So we have another array called difference. Okay, so let's have a value called previous. Okay, actually we can just do everything in one array. I realize we can just do a for loop for this whole thing. So previous equals to, okay, so previous will start with 0 already. Okay, so diff, actually I may not even need this vector diff. Yeah, we could just have the previous, and also we could have the, okay, so previous will be like previous number, previous num, and then we can have previous difference also. Okay, and then we could have like max. Okay, max could be an integer, but it's okay, we just do it max length, maybe max length. Okay, so we don't need to push back here, so we can just basically take the previous num. Okay, over here is update previous num. So previous num, come to think of it, I don't even need this array here also. Oh well, I can just do everything without an array because it's just one loop through. So previous num equals to x. So we update the current thing. So over here, first we do is get difference. So um, diff equals to x minus previous num. Okay, so I guess we need another diff here. And we don't need to initialize because we get the difference. Okay, if diff equals to previous diff. Okay, oh then we still need a count also. Count will start with 0. Actually we can just start the count with 1. Okay, if diff is the same as previous diff, then count plus plus. Okay, if not count equals to, okay, so max length will be equals to, okay, this one will be equals to 1 first. Okay, max length equals to max. Okay, I think C++ has a max method, yeah, which you can compare two numbers to get the max. So equals to max something something, so equals to max length and the count itself. So we update count if update max length if the difference is update max length if the difference is different. Okay, this sounds a bit weird, but the difference is not the same. Yeah, so over here we update previous num, we also update the previous difference. So previous diff equals to diff. Yeah, so we just keep doing this until we reach the end of the array. Okay, then we just need to print out the, we just need to print out the max length. Yeah, and this should do it. Let's try it. Let's try it. Oh, somehow it's not printing out the, it's printing out here as, oh, interesting. Okay, something went wrong with this code. Doesn't seem like it's printing out numbers. So, oh, I forgot to do one step. I forgot to see my end. Yeah, a silly mistake. Yeah, let's try running this again. Case 1 3, case 2 1, case 3 2, case 4 4. Okay, it's not exactly getting it right. Let's see why. Okay, case if diff equals to previous diff. count plus plus. Okay, else we reset this. The difference equals to x minus previous num, which is set to be 0 here. Yeah, so I guess if previous num is 0, then this doesn't affect this diff doesn't affect. Mm, let's see. Okay, see over here, this is 3, this is 1, 2. Let's see. Maybe we just print out the count so far so that I can like see how it is. So maybe we could just see out counts the space maybe. But that's that dark. Maybe I could just see out my counts so that I can like see what's going on. Okay, so over here, 1 1. So this is like 1. This is 1 also. Oh, something wrong here. Okay, 1 is okay because this is the first one, doesn't have anything. This one is fine. So the difference is 3 now. Then over here, the difference should be 3 at 1 here, 2. Okay, that sounds good. Then over here, the difference is not 3, so it resets. So it becomes 1. Then here, the difference is 2. So it adds 1, adds another one, 3. Oh, okay, okay, I get it. So over here, if the difference is, so we are starting here from scratch, 2, 3. But the thing is, if we start over here, we should actually take this difference like that. This 6 minus 4 will be the difference. So maybe when we start anew, we should make the count equals to 2 already, because like, yeah, maybe we should just start the count as 2, and then we just keep adding. So let's try this. So first case we got until 4. It's like 4, 3, 6. Oh, interesting. Okay, so it looks like it's correct already. Just comment this line and try again. 4, 4, 4, 2, 3, 5. Interesting. The last one it prints as 5, but over here is 6 when it's printed out. 2, 2, 3, 4. Correct. 2, 2, 3. I'm not sure why this is a 3 actually, because it's 5, 4, 5, 5, 4. This should be okay. Max length is max length count. So why is it not working? 2, 2, 3, 4, 5, 2, 3, 4, 5, 6, 5. Yeah, but on another note, it does look like it's wrong here, because like 5, 4, 3. Oh no, then this is correct. This is 2. After here is 2. Okay, then over here when the difference is updated, it'll be 3, 4, 5. Yeah, that's correct. Then when it comes here, it's 2, 3, 4, 2, 3, 4, 5, 6. So it gets until here already, counts until 6. Okay, but the thing is, because it still equals to previous diff, so count plus plus, maybe what I need to do here is also do this count equals to max length. Yeah, maybe I need to do this here also. Yeah, or no, just to make sure that for the last case, if the difference is still increasing, okay, then we manually do this last max length equals max length count. Okay, I think this should work. Let's try this. Oops. Let's try this. Actually, it's not very good to put over here because you may not be able to see my code. Okay, let me just adjust my window a bit. Or I mean, another way I can do it is to bring it up so that it doesn't block. You just make sure that you can see it, and if not, it kind of defeats the point. So let's copy and paste this. 4436. Awesome. I'll just do it like this. Yeah. Okay. Submit this code in C++. I wonder if I'll get all correct. I'm not too sure about this. There might be edge cases that my code fails to pick up. Okay, so let's see. Should be just a pretty simple problem where you look through. Okay, wrong answer. Okay, I need to find out where exactly is the wrong answer. Okay, okay, my difference or these are the same. Okay, so the whole array is an arithmetic array. Okay, either 555 or 456. Okay, over here is the last six. If mine gives a wrong answer for this, I need to find out why is there a wrong answer. Like 2 smaller equals n smaller equals 2000. I mean, count is 2 is natural because like you will definitely have an arithmetic array with any two integers. And then if the next difference is the same as the previous difference, then we add 1. I think that makes sense, right? That makes sense. The first case n is 2000, so it's not an issue with an integer limit. For the last case, the difference is still increasing. See out this. Okay, the fact that I got samples passed means the output formatting is correct. Okay, it just means that there might be some edge cases that it fails to detect. So let's just try to give ourselves some edge cases to test with. So like maybe one, let's have a sequence of 10 numbers 1, 3, 5, 7, 9, 11, 13, 15, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, last night 3. 9, oh, that's correct. Okay, let's try others. Let's try a whole array of like 6. 2, 3, 4, 5, 6, 7, 8, 9. It's working, but somehow it's not giving the right answer. The differences between consecutive number integers are equal. Okay, let's try another case. Maybe 10 numbers 1, 2, 3, 4, 5, 6, 7, 6, 5, 4. Oh, that's the issue. That's the issue. 1, 2, 3, 4, 5, 6, 7. It should be 7 numbers. 1, 2, 3, 4, 5, 6, 7. But then it counted 6, 5, 4 also. So okay, so maybe it's time to print out this to just check out why it's wrong. So maybe case 1, 10 numbers 1, 2, 3, 4, 5, 6, 7, 6, 5, 4. Okay, 2, 3, 4, 5, 6, 7, 8. Oh, okay. So it counted until 8 here, which is wrong. Okay, so uh, means that when I update this count should be 1. I mean, the original count is 2 is okay because the first difference will never be equals to the previous difference. Actually, that's not true. Yeah, actually, why not? Let's just do this. Or I is 0. Okay, so the count will always be 1. Okay, so if it's the first number, then always increment the count because you will definitely have the difference being the same. And then the next number comes in. Okay, actually, this one should be I smaller than 1 equals to 1 because like the first two numbers, we will definitely have the count to be added. Yeah, the first two numbers are fine. Then for subsequent numbers, count will be 1. Okay, because when we start the time, we already have the previous difference, and then that means there's always going to be two numbers already. So let's try this out again. 1, 2, 3, 4, 5, 6, 7, 6, 5, 4. Oh, wait. I need to do 10 numbers first. Oh, okay, let's try again. 1, 10, 1, 2, 3, 4, 5, 6, 7, 6, 5, 4. Very good, it prints out 7 now. Okay, let's see whether it works for the original cases. So my logic has some issues and rightly pointed out by the judge. I got a wrong answer. Just like somehow luckily it just passed for this test cases. That doesn't mean that it's correct. So now I got 3, 4, 2, 5. So it looks like I kind of failed in this test case again. I must be missing out something. Let's try to do this again. Okay, so the first case is 3. So let's see. This is 1, this is 2, this is 3. Okay, that sounds good so far. So far, so good. Then here's 1, 2, 3. One. Okay, so over here, when we start from here, I count it as 1, but actually it should be a 2. So maybe this one should be a 2 already. Okay, let's try again. 4, 4, 3, 6. Okay, very good. Let's make sure that this works. So something went wrong. 4, 4, 3, 6. Very good. Okay, let's try one more time. Let's try another test case. Let's try like 6, 5, 4, then 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 11. Okay, so this should be 7 or 8. 8. Yeah, it's 8. Okay, looks good. Looks good to me. So let's copy and paste and hope for the best. Oh, wait, wrong. Yeah, simple problem, but took me so long. Yeah, I think I took about 20 minutes coding this. It's just an issue with the logic. But I don't think this problem is difficult. It's just that my logic had some error just now when I was coding it. Awesome! See, we did it. We did it. Okay, high buildings. Somehow it seems that this. Oh, look at this toys and golden stone. So hard. Wait, let's see high buildings. High buildings. Oh no. Can I just set default? Okay, let's try to set this as default. Yeah, open your Visual Studio Code. Nice. Okay, so let's delete the soft option. Yeah, so it's good to do like that so that you don't have to code in the case numbers, but it wouldn't be too long also actually. Yeah, to code it in yourself. So in a unspecified country, Google has an office campus consisting of n office buildings in a line, numbered from 1 to n from left to right. In meters, height is between 1 to n inclusive. Adam and Sul are two Google employees working in this campus. On their lunch break, they wanted to see the skyline of the campus. Therefore, Andre went to the leftmost points, looking towards the rightmost part of the campus. Sue went to the rightmost, looking towards the left. A building X is visible if and only if there is no building to the left of building X. That is strictly higher than building X. Okay, Andre looks from the left to the right. Okay, And then okay, I get the problem. I get the problem. I mean, uh, Andre is like on the left here and looking to the right. Sue is on the right, looking to the left. And then if any building is higher than the building that they want to look at, it will be blocked. Okay, so let's see. Andre learned that there are A buildings visible to him. Sue learned that there are B buildings visible to him. After they regroup, they also learned that buildings are visible to both of them. They are wondering about the height of each building. Give you the value of n, a, b, c as their friend. You like to reconstruct a possible height for each building such that the information learned on the previous paragraph is correct, or indicate that there's no possible height construction. Oh, this is difficult. All right, all right. Let's see how to solve this. Okay, so firstly, uh, we take in n numbers. N is until 100. Okay, and then what's the input like that? N 4131 443. Okay, so 4131 4443. Case x y, where x is the test case number starting from 1. Okay, so we take in our test case. The first number is NABC. NABC, what's the ABC? Okay, so actually n is smaller than equals to 100. It means that all of them can be in an integer. So yeah, because n is the cap for this. So we see in n, a, b, c for each case. Okay, and we try to construct. So that means for this n is the number of buildings n. Okay, okay, and then a, b, and c. Okay, this is not that half after all. Yeah, so this is a, which is from a is looking from left to right. Okay, b is looking from right to left, and then c is visible to both of them. So left to right, he sees one. Okay, so over here he sees maybe, okay, so 1, 3, and 1. So this person, when viewed to the right, can see two buildings actually, 1 and 3. And then when this person views from the left here, can see two buildings also 3 and 4. How is it for 1, 3, 2? Only the first building is visible to Andre, while the first, third, and fourth are visible to Sul. One, this, or this two, and this one are visible to Sue. Also, they don't stand on the building here; they stand like somewhere here. So Andre, he sees from the right. He only can see this. Okay. Case two, all n equals 4 buildings are visible to Andre and Sue. Impossible to have c not equals to n. Yeah, if this four, if this one and this one are the same, that is not possible. Okay, for this case 5332, he sees 3, and then this one is only 2. So okay, I'm just thinking, over here if n is 5, right, that means test set 1 can essentially be brute force. Okay, you can basically just look through all permutations of the buildings can be from height 1 to 5. Okay, it doesn't really matter, it can be from height 1 to 5. Okay, so actually it looks like there's many possible ways to output this, and probably when they test your test case, it's not a static case. They will actually test whether view from left is 3, view from right is 3, that kind of thing. Yeah, but if you want to solve the test case 2 with 100 buildings, we cannot just do a permutation based approach, because permutation of 100 to the power of 100 is kind of big. Yeah. It's huge actually. It's very huge. So the way to solve this, okay, so over here this is one building. So you can see one, and then on the left, on the right here, you can see three. So one, two, three. And then I think this is the main thing. The buildings that are both visible to them. Yeah, I guess we could just do like the both visible to them. We can just make them the same height and make them huge and tall. Yeah, because that top building will confirm be visible for both of them. We can just make all of them the same height. Yeah, and then over here, then we can do the first set of buildings to make it lower such that this guy can see three. So one, two, three. This one can see three. So one, two, three. Yeah, so we can start with like the same height for the buildings that they can both see. Yeah, let's just do a simple solution. Okay, so we do from Andre's perspective first. We just optimize Andre's perspective. So like uh okay, so maybe over here we can have, okay, so we have a list buildings vector, integer building. Okay. I mean we can initialize it also. I think that's not necessary. Okay, so over here we can basically just optimize for Andre's side first. So vector. Okay, so for A and C, okay, so we do the C first. Okay, C, it means that there's a, okay, so if, okay, A plus B minus C, okay, if this plus this minus this, okay, is greater than n, that means it's impossible, right? Yeah, because you cannot see more than the number of buildings that are available. So else, okay, what we'll do is we'll basically okay, so I mean the last part here will be for int I equals to 0, I smaller than building uh, counts, the size I plus plus. Okay, if I not equals to building dot size C out, else C out and L. Okay, so over here we're just printing out the buildings. Okay, so over here we need to do the code to assign the buildings. So how do we assign the buildings? We need to, okay, so for the first case, for A, okay, we take A for int I equals 0, I smaller than A minus C. Okay, so actually there are three cases, or A smaller than C, because you cannot be seeing less than your combined, right? Or B smaller than C. So there are three cases where it's impossible. Okay, so if, okay, so I A 0, A smaller than C, I plus plus. Actually, we could do like we could do like this. Mm. So for the buildings until the tallest building, we can actually print this out. Actually, I may just, okay, I think we just do this. Yeah, we just, okay, so for combined buildings, okay, what we do is for int I equals to 0, I smaller than c, I plus plus, a building dot push back the, we want to push back the like tallest possible building, so it's like maybe we push back the case where it's like n plus 1, which is 5, which is like definitely taller than any of them. Yeah. Okay, so actually it's not n plus 1. We push back the, because the size of the height of the building must be kept by n, so we can push back height of n. So so the C, I mean the B case is Sul, so assign buildings for Sul. Okay, so we need to basically make sure that Su can only see certain buildings. Okay, so maybe what we can do is, okay, we just assign those that you can see first. For int I equals to uh, b minus c. Okay, I greater equals to 1, I minus minus. Okay, so this will print from b minus c to I. These are the buildings that you can see from the front. So building push back I. Okay, so for so this buildings here should be blocked. So for int I equals to 0, I smaller than, so we want these buildings to be blocked, right? So uh, over here we have b minus c to I greater equals to 1. Yeah, we want these buildings to be definitely blocked for so. So uh, it needs to be like b minus c minus 1, okay? Yeah. Or actually over here what I should do is I should make it such that this should be as high as possible. So I is n minus 1. Okay, I greater equals to n minus 1 minus b minus c. Yeah, so this will count down b minus c times. Yeah. So over here, these buildings we can safely just, if it exists, because here will be n minus 1 and here will be n, we can safely just push back a building of length of height 1, which is not possible for Su to see. So we can do this like this. I equals 0, I smaller than n minus b minus c. No, sorry, n minus a minus c. I plus plus building dot push back 1, because we want to, which neither can see. Okay, this one is use max height. Assign buildings for Andre max height. Hmm. Actually, there's an easier way to do this. I mean, I don't have to do it like in increasing order. Is there a limit to the number of buildings for each height? Yeah, it's, in fact, we can actually make all of this height n minus 1 also. We don't have to do something so complicated like this. But it's fine. Yeah, I think this should do the trick. Oh, building dot size. Guess we need to do this. Okay, find length of vector. Dot size, right? If I remember correctly. I think it's a dot size. Dot size, correct? Oh, my see out is in the wrong direction. Okay, let's try again. Oh, let's, I didn't copy the test case. Case one, 411321. Okay, something's wrong here. Case two, 15543. Actually, this is correct. Yeah. No, no, it's not correct. Yeah, because this is one too much. N minus one minus B minus C. Yeah, I want to print B minus C buildings, right? So, oh, this should be greater than, well, print one more, then it should be. So 41132 1554. Okay, so this one is correct. It is this one that needs to increase by one. N minus A minus C. Yeah, N minus A minus C. In this case, here will be 5 minus 3 minus. It should be like that. N minus A minus C. Yeah, which will tell us what is the N minus A minus B. Is it? Or is it this one? A plus B minus C. That's the combined buildings, right? So, okay, maybe it's this one. So, you take away what A sees, what B C, and then the combined one, like that. You add it back in. 15514. So, case one is 4132. That's correct. 15514. So, what do you call that? Andre can see 123. Sue can see 455. That's correct. Okay, let's just submit and see how it goes. We'll hope for the best. I just want to see whether my this code here is considered pass their test case or not, because I use a different kind of method to solve this thing here. So let's just see. Sample failed. Okay. Okay, it could be that my formatting is wrong. So let's try again. Oh no. Okay, so this one is to be minus one because like it keeps printing out a space. So let's try this again. Okay, let's exit this. Try this again. Okay, try this. Does it have a space here? I think it's fine. Yeah. All right. Hope for the best, and we see whether this works. I think this should be the correct code. I mean, I'm just using a construction that confirm will be right. Okay, so it solved the sample case. If I gives a wrong answer for test set one, so it means that there might be edge cases that this fails to work. Okay, so let's try one of the edge cases ourselves. We try to do maybe one of the edge cases. 4 buildings. Andre sees 4. Okay, and then the other guy sees none. Okay, this is impossible. Okay, because the other guy must see at least one. You see, this is considered one already. So it means that the impossible case I didn't update it correctly. So C must be definitely one because both of them cannot see. So C is zero. So if C is zero, it's confirmed wrong. Okay, because that's the edge case. Okay, so let's try again. Four. Okay, first guy sees three, second guy sees three, and the middle sees three. So here is three. Okay. Ah, here it cannot be three also because this person sees four. So if they both see three, it means that the three buildings that they both see cannot be of the same height. Because like over here, this is three, but here, by nature of the fact that this is a one, I mean, I cannot make this taller. So in order to solve this case, like they need to be able to see. Mm, yeah, there's some edge cases that I failed to take into account because of the other side. I mean, for this Andre guy, confirm is correct because like we already cater into account all that he can see from the beginning to the end. But for the other guy, we did not do that. Okay, we did not do that. So if let's say we want to do 4 3 3 3, so this guy sees three, the other person sees actually four, and combined they see three buildings together. So this can be the combined three that they see. Okay, but it's not possible for them to combine and see three buildings. Okay, when they combine and see three buildings, the buildings must definitely be of the same height. Because if the building is one shorter, one tall and one short, then one person can see, but the other person cannot see. So the buildings must be of the same height for for this C. So what this means is that this should be an impossible case. Okay, so my impossible case is not robust enough. Okay, let's see how to solve this. So this is 3. So from the other point of view, okay, if this is 3 also, so A plus B minus C is greater than N. So A plus B minus C so far is 3. Mm, okay, if A equals to C and B equals to C, okay, let's just try 4 3 3 2 first. Yeah, this is correct. 4 3 3 1, impossible. Okay, so 4 3 3 2 is okay. 4 3 3 3 on the other hand should be impossible, but how do we code this? A plus B minus C. A plus B minus C is 3 plus 3 minus 3, which is 3. Okay, think about it. Okay, 3 on this side, 3 on the other side. Okay, but on the other side, what I need to do is I need to actually add in the fact that you can actually see one more building than the minus C here. You can actually see one more building because it's necessary for you to see one more building. So if the combined building is 3, my this B cannot be smaller than C. I mean cannot be equals to C. Unless the number of buildings is n. So maybe we could add one more case here. B equals to C and B equals to C and A equals to C. n. Yeah, this is not possible. There's no way this is true because one of them must be able to see something. Okay, let's try this again. Oh, great. Okay, let's try for 5. Okay, so maybe okay, 5333 is impossible also. Is it impossible? Yeah, it'll be. Oh no, it's not impossible actually. Oh, it's not impossible. Oh, this is wrong. This is wrong. I shouldn't put here. I realized something. In this 4333 case, it's perfectly possible for them to see only 3 by putting one unseen building inside the. So rather than 4333, rather like 4441, we could do like 4414. Like we could do the small building inside that cluster of tall buildings. So it is possible to achieve this. Yeah, it's possible to achieve this. Mm, so actually, this should be an yeah. So this gives you b minus c. Okay, this gives you b minus c. So it's like saying I equals to 4, I greater than, let's say b minus c is 1. Okay, but if b minus c is 0, okay, let's see this again. So maybe do 4, 4, 3, 3, 3. Okay, so now it's impossible, but actually it's possible, I realize. Oh, I didn't save this yet. Cheeky, this Kickstarter. Give me a give. Don't give all the cases. Yeah, so it is possible. We just need to put this one over here. Just need to put this one in the middle of the force. Then it's possible already. Okay, 4343 is possible also. Yeah, actually this is correct. Yeah, it's correct. How about 4434? Okay, so that's not possible. That's correct. Let's try again. 4443. Okay, 4433. Yeah, it works. Okay, it's now only the 4333 case that is not correct. Okay, because of the way this works. So this uh, this part here, n minus 1 minus b minus c, this is not doing the job well because we did not take into account this part here, buildings which neither can see. I guess what I need to do is I need to put this neither can see somewhere here. So so we need to do two cases. So if c is greater than 2, okay, then we can possibly do else if c greater than 2, then we can actually do this, like we can do until c minus 1, and we do this, then building dot pushback. Yeah, we can basically put an unseen building inside here. So building dot pushback, and we could do this. So this is unseen buildings. Okay. If c is not greater equals to 2, there's no way that we can do an unseen building for either side. Else we gotta do this whole thing. And then we should assign this part here. Okay, there's a slight issue here. If c is 1, neither can c. Okay, let's just try this out first. 4, 3, 3, 3. Very nice. Okay, so if let's say my buildings that neither can see is quite high, so maybe like 4, 1, 1, 1. Yeah, then this proves to be a problem because like we can only see one, but here confirm we can see this building. So this is a case that we should put as impossible. So if the common building is 1, it should be impossible because yeah, if the common building it's 1, then one person will have to see 2, right? If n is greater than a certain value. Because when c equals 2 is okay to hide, but when c equals 1 it's not okay to hide. One person will definitely have to see 2 buildings by nature of the fact that based on this tallest building, there should be still some smaller buildings on one side. One person confirm will need to see more than one. Okay, so c greater than c equals to 1, and okay, if c equals to 1 and okay, let's think of it from B's perspective. Okay, A confirm can A, if A is 1 is fine. Yeah, because we can always, and B equals to 1, and N not equals to 1. Yeah, if this is the case, that means you cannot see from the other side. Okay, let's try again. Impossible. So let's say we saw 2, 2, 1. So this person will see 2, this person will see 2. We hide the buildings inside here. Okay, here we cannot really hide the buildings, but get the point. So 4, 2, 3, 1. This person sees 4. Sorry, this person sees 2. Other person sees 3. Okay, very good. Okay, I think this is probably one of the last attempts that I'm doing for this, because if it's still a wrong answer, it's just the special cases that is not settled. It's not an issue with the algorithm itself actually. It's more like we need to think of the special mathematics cases where a certain value can be greater, a certain value can be smaller. Yeah, so I'm just going to look at the analysis and see what I miss out. Yeah. Okay, let's see what I miss out. Yeah. C greater than 1. Consider any values PQ. Can put A minus C buildings on the left, B minus C on the right. C buildings in the middle of height Q. Okay. You cannot hide buildings in between buildings with maximum height. And there's only one of them. Yeah, we're going to look for some cases here. A plus B minus C equals to N. No buildings to hide. Okay. Either A greater 1, B greater than 1. In the case we a plus b minus c smaller than n. I think I may be missing this building, this case. The building in maximum height is both on the leftmost point and on the rightmost point. It's impossible for both a and b to be 1. Okay, let's try this again. Yeah, it's a pity that they don't give partial credit because like I'm pretty sure the code will have worked for most cases. It's only certain cases that it will fail to work. And you need to really enumerate all the possibilities in order to find out what are the cases that didn't work. I think mine didn't work for the, oh, there's more that didn't work. Okay, c equals 1, we cannot hide the buildings behind buildings. Okay, a plus b minus c equals to n, not, no buildings to hide. Either a greater than 1 or b greater than 1 in this case. Oh, actually a and b cannot be 0, right? So I might miss out the case also where a and b cannot be equal to 0. I might miss out this case because it's not possible for you to have 0. Yeah, but they didn't say that their ABC is, they didn't say that their ABC must be constrained by, oh, actually they did. C, yeah, they did. So A and B cannot be 0, but it's okay, I can just put it here. Okay, either A greater than 1 or B greater than 1. Thus, we can say that n greater than 2 holds. These three I can pick out. They won't give 0 values. Okay, so there must be some case I'm missing out over here. This is a difficult problem actually. I mean, it's deceptively simple, but there's so many edge cases that is not even represented in the test set, which makes it difficult. I'll think about it. But yeah, just need to follow this case. I mean, I'm pretty sure this case I got it settled already. It's only this case here that I need to implement something to code it out. Yeah, but I've got to go already. So yeah, So you're down to continue this tonight. Yep. If not, thanks for watching, and yeah, do join me in round E2021 if you're interested. Round E2021 is in 8 days, 17 hours, 8 minutes. So that's about, oh, that's just nice in the afternoon for me on a Saturday. Yeah. All right. So see you all and have fun coding. Bye.